Look up tonight. Every galaxy out there is being pushed away from you right now. And the thing doing the pushing was supposed to be the one part of the universe that never changes. Fixed, unchanging. So steady that we build the word into the name of our standard model of the cosmos. A new map of the sky just suggested it was never fixed at all. In the next few minutes, you'll find out why the force stretching the universe may be shifting under our feet. Why there is a proof saying that shift should be impossible, what one telescope saw after mapping more than 30 million galaxies, and why the same idea might delete the Big Bang from the story of everything. Which leaves a question with no comfortable answer. If this push is not a constant, then what is it? How do you measure something you cannot see or bottle or switch off? Hold on to that. Go back to 1917. Einstein has just rewritten gravity, and his own equations will not sit still. The universe they describe either collapses inward or flies apart. Neither matched what anyone believed at the time. So he added one extra term by hand to hold it steady. He called it the cosmological constant. Remember the name because it comes back. It is a fixed amount of push built into empty space itself, not something floating in space. A property of space. Take a sealed box containing absolutely nothing and it still pushes outward. Then the universe turned out to be expanding on its own, and the extra term looked pointless. Einstein came to see it as a mistake. He threw it out. It sat in the discard pile of physics for 80 years. 1998. Two rival teams are hunting exploding stars billions of light years away and using them as measuring sticks. They expect to catch the expansion slowing down. Gravity pulls. Everything with mass is tugging on everything else. The light comes back too faint. The stars sit further away than they should. The expansion is not slowing, it is accelerating. Nobody had ordered that. Something is beating the combined gravity of every galaxy in existence, and it does not weaken as space grows. We named it before we understood it. Dark energy. So the discarded term was pulled back out of the bin. Ordinary matter. Dark matter. A constant push that never fades. That recipe became the standard model of the universe, and it fits almost everything we can see. Which is exactly what makes the next part so awkward. How wrong can a prediction be and still come from our most successful theory of nature? Ask quantum physics how much push empty space should carry. It answers immediately, and it answers with total confidence. The number it hands you is too large by more than 120 orders of magnitude. That is a 1 followed by 120 zeros. Try to feel that. Guess the weight of one grain of sand and be wrong by the combined weight of every star in the observable universe. You would still be far closer than physics is here. This is not a rounding error. It is the widest miss anyone has ever put on paper. There is a second problem, and it is quieter. Matter thins out as space stretches. This push does not. Their strengths should almost never match. Yet right now they sit at roughly the same level. Out of billions of years, we happen to be alive inside the narrow window where the two agree. Why us? Why now? Then more cracks opened. Measure today's expansion rate 2 different ways and the 2 answers refuse to meet. Measure how clumpy matter has become, and the numbers argue again. The oldest light in the sky carries patterns nobody predicted. Each crack is small. Together they look less like noise. And here is where a common idea needs fixing. Dark energy sounds finished. It has a confident name, and a symbol in the equations, and a paragraph in every textbook. It is not finished. It is one of the largest unsolved problems in science, and its single most basic property is now in doubt. Physicists squeeze all of this into one number. Picture a dial describing how the push behaves while the universe grows. Set that dial to -1, and the push stays perfectly constant forever. That setting is Einstein's old term exactly. Every textbook picture assumes the dial is glued there. Turn it slightly above -1, and the push slowly fades over billions of years. Turn it below, and the push strengthens without limit until it shreds galaxies and eventually atoms. 2 space telescopes spent 20 years reading that dial. Every single time the answer landed on -1. If you like watching the universe quietly break its own rules, then subscribe. It costs you nothing, and it keeps stories like this one finding you. So what happens the day the dial stops sitting still? Around 2022, the supernova catalog started nudging. One drifted, then a second, then a third, not a leap, a lean. And it leaned the same way every time. There is a name for a dial that does not merely drift, but crosses the line. Quintum. It means the push behaved one way early in cosmic history and then flipped to the other side of -1. Not fading, not growing, switching character partway through the life of the universe. And that is where physics slams a door. There is a result called the no-go theorem. It proves that no single simple field and no single simple fluid can ever cross that line smoothly. Not difficult, not unlikely. Forbidden. It was proven on paper long before anyone had data pointing at a crossing. The reason is brutal. Right at the crossing point, the speed at which ripples travel through this stuff blows up toward infinity. The whole thing turns unstable and falls apart mathematically. Real physical fields do not behave like that. So if the crossing is real, then the simplest explanations are all dead. Which leaves only expensive escape routes. Use 2 fields instead of 1. And the second one needs a ghost carrying negative energy. Change gravity itself and dark energy stops being a substance at all. It becomes an illusion created by gravity misbehaving at the largest scales. Or let dark energy and dark matter secretly trade energy for billions of years. Every route carries a price, and none of them can be ruled out with the data we have. Telling them apart means watching how matter clumps under each one. Gravitational lensing. Gravitational lensing. Gravitational waves. The twist in the polarization of ancient light. And if this field touches ordinary matter, it might even explain why anything survived the Big Bang instead of annihilating. So what did the biggest map of the universe ever attempted actually see? On a mountain in Arizona sits a telescope fitted with thousands of tiny robotic fibers. Every night they swing into position to catch light from separate galaxies. The goal is a 3-dimensional map built from more than 30 million galaxies and quasars. That is more than any sky survey before it by a wide margin. Not a photograph, a map with depth and time baked in. The first data release landed in 2024. Combined with supernova catalogs, it disagreed with a constant push at up to 3.9 sigma. Sigma is simply a way of asking how easily a fluke could fake this. And it pointed straight at the crossing. The dial had moved. Then came the second release with sharper measurements and smaller error bars. Paired with the oldest light in the sky, it prefers a changing push at 3.1 sigma. Add the first supernova catalog and it reaches 2.8. Add the second and it climbs to 3.8. Add the third and it hits 4.2. The tempting objection is that one clever method produced all this. It did not. Analyses that assume no shape for the dial at all reach up to 4.3 sigma. Different methods, different assumptions, different assumptions, different data combinations. They keep landing in the same corner, and it is the quintum corner. Now the honest part. This is a strong preference in the data and not a confirmed discovery. Physics demands 5 sigma before it uses that word. That is the bar the Higgs boson had to clear. Euclid and the Vera Rubin Observatory. And the next generation of microwave telescopes will settle it. And one more twist is waiting. Run the standard universe backwards and you crash into a moment where density and temperature go infinite and every equation dies. The exact crossing behavior this data favors is also the ingredient needed to avoid that. A universe that contracts to something small and finite, then bounces back out. Physicists call it bounce cosmology. Think about what that means. The tool built to explain why the sky is flying apart today may be the tool that removes the beginning of time from the story. We assumed the universe ran on something simple and fixed. Simple may turn out to be the most expensive assumption we ever made.